Today, we're going to dive into a medical mystery. We're on the hunt for a hidden cancer clue, one that's super easy to miss because it's not at all what we've been trained to look for.
You know, we're all taught to check for a lump, right? It's that clear, obvious sign something's wrong. But what if the very first warning sign wasn't a lump at all? What if it was something way more subtle, an almost invisible disturbance hidden in the very blueprint of the breast tissue?
Well, it has a name: architectural distortion. And the stakes here are incredibly high. This subtle little clue is one of the toughest challenges in breast imaging, but it could be an early warning. So, let's start the investigation.
Okay, so what in the world are we even looking for? I mean, how do you define something that's famous for being so hard to see?
The official definition calls it a disruption of the normal breast tissue pattern, with no definite mass visible. So, the key here isn't to find a lump, it's about seeing the effect of something pulling the tissue inward. The best way to picture it is to imagine a pucker in a piece of fabric. See those thin, straight lines all radiating from one little point? That's exactly what we're talking about. That's the clue.
So, let's look at some evidence. Here on this mammogram, you can see that classic starburst pattern. Look at those thin white lines shooting out from the center. Radiologists call those spiculations, and it's the dead giveaway that the tissue is being pulled in. In this particular case, it was caused by an invasive cancer.
Okay, now let's switch tools and look at an ultrasound. The clue looks totally different here, which is fascinating. Instead of that starburst, we see this shadowy, dark area that's kind of messing with the normal, neat layers of tissue. It's the same puckering effect, just viewed from a completely different angle.
And for our third piece of evidence, the MRI. And there it is again. You can still see that central pull, drawing all the surrounding tissue toward it. What's really tricky is that sometimes these areas don't even light up with the contrast eye, making them even harder to spot. Seeing this pattern across different types of imaging is just fundamental to cracking the case.
All right, so here we get to the central mystery of it all. Just because you find this distortion, it doesn't automatically mean cancer. The big question for the medical detective is this clue a friend or a foe? Is it harmless, or is it pointing to something life-threatening?
This table basically lays out our list of suspects. On the harmless side, the benign causes, you've got things like old surgical scars. But on the malignant side, you have the really dangerous culprits like invasive ductal carcinoma or invasive lobular carcinoma. As you can see, both good guys and bad guys can create that exact same deceptive puckering effect.
And if you really want to see how tough this is, just look at this comparison. On the left, that distortion is from a harmless surgical scar. On the right, it's from an invasive cancer. To the naked eye, they look almost identical. This is the massive challenge that radiologists are up against every single day.
So when the clue is this deceptive, what's in the toolkit for the investigators? How do they solve the puzzle? Well, the biggest game changer by far has been 3D mammography, or what's technically called digital breast tomosynthesis. Just look at the difference. On the left is a standard 2D image. It's flat, so all the tissue is squished together and it could easily hide the distortion. But on the right, the 3D view slices through the breast one layer at a time, getting rid of all that overlap. And bam! Suddenly that starburst pattern just pops. It's like the difference between looking at a book cover versus actually flipping through the pages. And the impact of this is just huge. By getting rid of that overlapping tissue, radiologists can now pinpoint the exact location of the distortion with incredible accuracy. And the result? They've nearly doubled the detection rate for this super subtle clue compared to old-school 2D imaging.
But technology is just one piece of the puzzle. The real secret sauce is a systematic approach. First, the detectives review the patient's history. Is there a past surgery that could explain this? Second, they use all their imaging tools together to get the full picture. Third, they hunt for any associated clues, like tiny calcifications. And finally, if there's no innocent explanation, a biopsy is the only way to know for sure what's going on.
Okay, so let's walk through a real-world case to see exactly how this whole process plays out, from start to finish.
So our case kicks off with this mammogram from a 35-year-old patient. The radiologist immediately spots a very suspicious area of architectural distortion. And since there's no history of surgery to explain it, the investigation is on.
So, the plot thickens. They do an ultrasound to get another look, and it reveals this irregular, spiky-looking mass right where the distortion was. In the world of breast imaging, that kind of appearance sets off all the alarm bells. A biopsy is ordered right away. And here is where our story takes a major twist. The biopsy results come back.
and they're benign, harmless. But this quote here is the most important part of the story. The results are discordant, which is a fancy way of saying they just don't match the pictures. A benign sample doesn't explain why the imaging looks so much like cancer.
Now, this is where real expertise comes into play. A less experienced team might have just stopped there and said, great, it's benign. But because of that discordance, the radiologist knows the case isn't closed. The only way to be 100% certain is to recommend a surgical excision, to actually remove the whole area and get the final definitive answer.
So, what was the final verdict after surgery? A benign radial scar. One of those tricky cancer imposters we talked about earlier. It looked really dangerous, but it was totally harmless. And thanks to that rigorous process of questioning the evidence, the mystery was solved. The pathology finally matched the imaging, and the case was closed. Concordant.
So why go through all this intense detective work? Well, this number says it all. When architectural distortion is found on a 3D mammogram and there's no scar to explain it, the malignancy rate is nearly 20%. That means almost 1 in every 5 of these subtle, nearly invisible clues turns out to be cancer.
So if there's one thing to take away from all this, it's that architectural distortion is a subtle but an absolutely critical sign. If there isn't a clear history of a scar in that spot, this finding has to be considered suspicious until it's proven to be benign. You just can't ignore it.
It really makes you think, doesn't it? As our imaging technology gets sharper and sharper, and our understanding gets deeper, what other invisible clues are we going to learn to see? What other hidden signs are just waiting to be discovered in the fight against cancer?